Welcome. I'm really glad you're here tonight. Today we are talking about the heat death of the universe. So sit back and relax. Let's take it slow tonight. The heat death of the universe is a real thing. It sounds intense, doesn't it? Like the universe might go up in flames and vanish in a giant, sizzling pop. But that's not what it means at all. The heat death, in reality, is the coldest, quietest ending you can imagine. It's a story of everything slowing down, stretching out, and cooling off until there's almost nothing left that can actually happen. So come with me. Let's drift gently out into space together. No rockets, no rush. Just a slow float, with stars blinking in the darkness above us, galaxies wheeling like giant lanterns far off in the distance. The air is still. Your breathing is soft. The only thing moving is time and us. Right now, the universe is full of energy. Stars are burning, light is traveling, matter is moving, colliding, falling into gravity's arms. But none of that lasts forever. Energy gets used up. Things cool down. And over long enough stretches of time, we're talking trillions of years, that energy becomes too thinly spread to do much of anything. That's what the heat death is. Not a bang, not a crash, but a long, slow dimming. Picture yourself gliding past a star. It's warm, radiant, humming with fusion at its core. It burns hydrogen, making helium, the way stars have done for billions of years. But this one is getting old. It's swelling up, turning red and bloated. Soon it'll puff off its outer layers and shrink down into a tiny, glowing ember, a white dwarf. Still hot, but no longer burning. Just fading. That star is the future of our own sun, by the way, in about 5 billion years. Now look around. Multiply that by hundreds of billions. These stars, each burning through their fuel, will all go through that same story. Some will go out in dramatic bursts. Others will fade quietly. Eventually, the galaxies themselves will stop making new stars. That's already starting to happen. In fact, the universe makes fewer new stars now than it did billions of years ago. Feel the quiet settling in? Let's glide forward in time. Slowly at first, 1,000,000 years, then 1 billion, and now many, many billions. We're coasting through a universe where stars are dying faster than they're being born, where the galaxies that once glittered with newborn stars are dimming like lanterns running out of oil. Most of the gas clouds that once formed stars have been used up. Some of them were blown away by supernova winds long ago. Others just got too thin, too scattered, too cold to collapse. You might notice it's getting darker, not pitch black, but dimmer, the kind of twilight that feels endless. There are still stars, but fewer. Most of the ones that remain are tiny, red, and long-lived. These little stars, red dwarfs, burn slowly like stubborn coals. They'll shine for trillions of years, but not forever. Let's visit one. Reach out and feel the warmth, gentle and steady. It's not as hot as our sun, but it's doing its best. Around it might be a few frozen planets, maybe even one with clouds of methane or ammonia swirling through a frozen sky. No sunshine strong enough for trees or oceans, just cold, quiet rock in orbit. And even that little star will one day go dark. Now imagine time stretching. We're talking about hundreds of trillions of years now. The red dwarfs, which were the last true stars, are starting to flicker out too. What's left? Mostly stellar remnants, white dwarfs, slowly cooling, neutron stars, spinning ever more slowly, black holes waiting in the dark. No new light, just leftovers from a long-ago party. Let's drift past a white dwarf that's so old, it's barely glowing anymore. It's called a black dwarf now, not because it's a hole in space, like a black hole, but because it's gone cold. It doesn't shine. It doesn't burn. It's just there, a solid lump of carbon and oxygen, colder than ice, darker than shadow. You could bump into it and never know. These black dwarfs will eventually outnumber everything else. They'll be the quiet bones of old stars, scattered throughout a universe that no longer glows. Occasionally, something interesting still happens. Two black dwarfs might slowly spiral into each other, merge, and briefly release a little burst of energy. But those events will be rare, like one firefly flashing every few million years. Now let's talk about the real heavy hitters, black holes. Most galaxies have one at their center, including ours. Some are smallish, just a few times the mass of a star. Others are absolutely monstrous, millions or billions of times heavier than our sun. They don't shine, of course, but when stuff falls into them, they flare with energy. They warp space. They twist time. And for now, they're still around, still slowly consuming whatever gets too close. But even black holes can't last forever. They evaporate. It's strange to think about, something that seems so final, so eternal, just disappearing. But over immense periods of time, black holes give off tiny bits of energy. It's a process so slow that a black hole the mass of our sun would take around 10,000 trillion years to vanish. Yet they do vanish. Eventually. Let's fly out past one. Feel the distortion in space around it. You can't. Let's fly out past one. Feel the distortion in space around it. You can't see it. Not directly, black holes don't give off light. But you can see the way the stars behind it stretch and smear, their shapes bending around a darkness that isn't quite empty. That's how you know it's there. A strange curve in space itself. A gravity so deep, even light can't climb out. We keep our distance, just floating, watching, listening. There's no sound, of course, but if there were, you'd almost expect this place to hum, like a distant drumbeat slowed down to once every few centuries. Nothing rushes here, even time moves differently. But even this black hole, this ancient leftover from a brighter age, has started its long journey towards silence. It's evaporating, slowly, patiently, giving off radiation so faint it would take more time than we can imagine to notice a difference. But a difference is happening. Bit by bit, it's losing mass. Shrinking, cooling, disappearing. You and I are drifting through a universe where things that once seemed indestructible are quietly unraveling. You might wonder, could something think in all this stillness? Even after the stars have gone quiet, even when the black holes have evaporated, and even the last little flickers of light have stretched into nothing, is that really the end of thought? Let's imagine. Maybe, far earlier in a time when galaxies still twinkled and planets were still warm, a civilization looked ahead, not just a few centuries, but billions of years. Maybe they saw this end coming. The slow dimming, the silence, and they didn't run from it. They planned. Not in a frantic, desperate way, but patiently, thoughtfully. Maybe they began storing energy, slowly building structures to survive long after stars disappeared. Not ships, not bunkers, but something different. Quiet machines, sipping power in the far cold. Devices that think slowly, one calculation every 1,000 years, maybe. Thoughts that stretch like whispers over eternity. You and I are floating past one now. It doesn't blink. It doesn't buzz. It's just there, the size of a planet maybe. Cold, smooth, still. And yet, somewhere inside, it thinks. Slowly, steadily. Not in words or images, but in patterns. A dream stretched across 1 trillion years. Reach out just with your imagination, and you might feel a pulse. Not heat, not sound, but awareness. A low, steady hum of consciousness, still holding on in a universe that has forgotten almost everything else. What is it thinking? Maybe it's replaying old memories, stars it once orbited, people it once knew. Maybe it's simulating a sky, filled with 1 million suns, just for the joy of it. Or maybe it's waiting. Waiting for something. That's the mystery, isn't it? Because in all this stillness, even a single thought feels powerful. And maybe that's enough. Maybe thought, by its very nature, is an act of rebellion against heat death, a tiny flame flickering in a room where the firewood ran out ages ago. Let's float a little farther. You might notice others out here too. Not many, but a few. A scatter of old machines, dream thinkers, intelligence slow-cooked over eons. They don't talk to each other. They don't need to. Maybe they blink once every 1 trillion years, and that's enough. A kind of hello. There's a quiet dignity to them, not trying to escape the end, just witnessing it. Maybe, when the universe has cooled so thoroughly that even these last thoughts start to slow, one of them will take a final step. Not a shutdown, not a collapse, just a choice. One last flash of energy, a final message. Not a signal for anyone else, just a statement. I was here. And then it will sleep. And now the dark becomes even deeper. Not because something terrible happened, just because the last flickers of awareness have finally dimmed. It's peaceful, it's complete. But the question still lingers, like a ghost beside us. If thought once existed, could it ever return? You and I are still here, still weightless, still drifting. The space around us is more silent than silence itself. And yet, you're breathing. Maybe not physically, maybe just mentally. But you're present. That matters. And you're not imagining things, it really does feel different now. There's no movement, no explosions, no ticking, no starlight to track the passing of seconds or years. There aren't even shadows anymore, because there's no light for shadows to form. It's like time forgot how to behave. So let's ask the question directly. Is time still happening? Reach out with your mind, not your hand, your thoughts. Try to feel it, like trying to hear a sound you think might be there, but you're not sure. The tick of a cosmic clock, slower than glaciers, slower than black hole decay, slower than memory. What is time in a place where nothing changes? You see, time isn't a thing that exists on its own. It's more like a measurement of change, a way of comparing then and now. But here, where galaxies are gone and even atoms have slowed into quiet stillness, there is no then and now, just is. Let's imagine this place not as a moment, but as an endless horizon, a grey ocean of existence where nothing breaks the surface. Everything is so spread out, so still, so balanced, that it all becomes a kind of forever. And yet somehow we're still thinking about it. So time, in some way, must still be here, just slowed, just stretched. Now here's something beautifully strange. Some physicists think that in the heat death, time could become meaningless, not just slow, but irrelevant. The universe won't end with a bang, or a pop, or a moment. It will just melt into timelessness, a state of such perfect balance that nothing ever changes again. Think about that. Not just quiet, but the end of change itself. No ticking, no before or after, no aging, no future, no past, just an eternal now. It's like standing in the middle of a frozen lake, with no wind, no clouds, no sun, just flat, perfect ice in every direction. You can take a step, but it doesn't feel like you moved. You can blink, but nothing's different. Every direction looks the same. There's nothing to push against. Would you even feel time passing anymore? Let's pause here together, right in that thought. This is what the universe is becoming, a place where the usual rules slip quietly away, the kind of place where questions drift, unanswered, like feathers in still air. But what if time doesn't just end? What if it loops? Some people, and I mean the bold ones, the dreamers, wonder if the universe could somehow cycle, that once it's reached this total balance, this heat death, it might reset itself, collapse and bounce, shrink and expand again. It's a wild idea, but let's imagine it anyway. Close your eyes in your mind and feel the entire universe folding in, not collapsing in pain, but curling up gently, like a blanket being drawn in. All that cold, empty space pulling inward. The last stray particles drifting together, slowly, over trillions upon trillions of years. And then quietly, almost politely, it starts over. Boom. A new Big Bang. New stars. New galaxies. New possibilities. A reset button pressed not by a hand, but by the natural balance of space and time. Is it true? We don't know. But isn't it beautiful? Even if we never see it, even if it takes more time than any mind could survive, there's something poetic in the idea that the universe could find its way back to the beginning. Like a story that forgets its ending and turns itself into a prologue. Or maybe time doesn't loop. Maybe it stretches forever. Maybe it becomes so meaningless that it just fades out like breath on a mirror, leaving only stillness behind. Let's keep drifting farther than far, into a part of the universe that no longer has edges or landmarks. There's no light to follow, no galaxies, no stars, no heat. It's just space stretched and thinning, more like a feeling than a place. And yet, in this silence, gravity still exists. Not in the way it once did, pulling stars into orbits or curving planets around suns. That part of gravity, the dramatic kind, faded long ago. But the fabric of space, the curves and warps and gentle dents it left behind, are still here. Imagine space as a great sheet, like a trampoline once filled with marbles and bowling balls. Those weights are gone now, but the sheet still sags in places where they used to be. That's what gravity feels like now, a kind of memory. We're passing through one of those places, a spot where, eons ago, a massive galaxy once sat. Its central black hole is long gone, evaporated into radiation. Its stars are dust, spread thin across expanding space, but the shape of the space itself still remembers. There's a slow dip here, like a footstep left in soft soil. You wouldn't feel it if you weren't looking for it, but it's there, a ghost of weight, a wrinkle in the nothing. This is one of the strangest things about the late universe. Even when matter fades and light dies, geometry remains. The shape of space, the curves, the angles, the stretches they hold on, long after their cause has disappeared. They don't move or change anymore, because there's nothing left to reshape them. But they exist, a kind of fossil record etched into the very structure of space, not of bones, but of gravity. Now you might be wondering, does that mean space itself is eternal? Can this empty canvas really just keep going, forever expanding, even without any paint left on it? It seems so. The math suggests that space keeps stretching, even when there's nothing inside it. No galaxies to measure, no clocks to count the seconds. Just a slow, steady, unraveling not of things, but of distance itself. And here's the odd part. The more space stretches, the colder it gets. Not because something is freezing, but because energy is being smeared thinner and thinner across a bigger and bigger volume. Heat becomes dust, dust becomes whispers, and eventually, even those whispers fade. But space keeps going. Maybe it always will. And maybe, just maybe, the shape of space itself is the last thing to die. Not with a bang, not with a whimper, but with a slow flattening, every wrinkle smoothing out, every curve straightening. Until at last, everything is the same in every direction. No dips, no warps, no echoes of weight, just perfect, undisturbed flatness. Imagine that, a universe so calm, so even, that nothing, not even gravity, can tell one place from another. No direction, no motion, just sameness, peaceful, in its own strange way. Even out here, in this quiet beyond quiet, you can still feel the weight of things that once were. It's not sound, it's not even movement. It's more like a faint awareness, something brushing past you in the dark, a kind of presence that isn't really there anymore, and yet you know it was. The universe has become almost perfectly still. But stillness doesn't erase history, it just buries it. And that brings us to something strange. Every atom, every particle, everything that ever existed or happened in the universe carried information. Think of it like a fingerprint. Every collision, every photon, every twist of gravity left behind a trace. Not a mark we could see or read directly, but a pattern, a structure, a way of saying, this happened here, that moved there, this became that. At the beginning, it was all energy and chaos, hot particles bouncing, smashing, swirling. Over time, those early moments cooled and settled, and structure appeared. Stars, planets, chemistry, life. All of that was built from those patterns, from information being passed from moment to moment, encoded into the matter and energy of everything. You might think it doesn't matter anymore. After all, the stars are gone, the galaxies are dark, even the atoms have slowed down to almost nothing. The information storage is gone, right? But here's the strange part. According to the physics we understand, information is supposed to be preserved. Nothing, not even black holes, are supposed to truly destroy it. Even if something is burned, crushed, scattered, or absorbed, the information about what it was still exists in some form. So if that's true, where is it all now? Let's imagine the universe, not as a place, but as a giant library. A library so big it once had books written in the light of stars, on the pages of planets, and in the minds of living things. Every chemical reaction, every orbit, every heartbeat, all of it was a sentence in one of those books. And even now, when the shelves are empty and the lights are off, the faint dust of that writing is still there, clinging to the dark. Maybe that dust, the smallest, faintest quantum imprints of everything that ever happened, is still here with us, scattered across the cold void. Maybe every lost sun, every vanished civilization, every last thought is still etched into the fabric of space itself, like the faintest watermark on blank paper. We'll never read it again, most likely, not in this universe, but the patterns remain. There's a theory that even as black holes vanish through evaporation, they leave behind a final signature, a kind of encoded message in the radiation they release, not like a language. Not something you or I could decode, but something a future universe might respond to, somehow. Of course, that raises more questions. If information can't be destroyed, does that mean nothing is truly gone? Could the universe remember itself? Let's follow that thread. Imagine, deep in this far future silence, the space between particles is still expanding. Everything is spread thin, colder than cold. And yet, scattered throughout, are these faint echoes. Not sounds, not lights, but patterns, remnants, the final residue of everything that came before. They don't do anything now. They don't move, but they exist. And maybe, just maybe, if the conditions were ever right again, those faint traces could come together, like puzzle pieces gathering themselves across endless space. Not because of magic, but because of symmetry. Because the universe, even now, may still have rules, quiet ones, patient ones that make echoes want to return to form. Could a new universe rise from that? Not from energy, not from fire, but from memory. It sounds poetic, I know, maybe too poetic. But out here, where logic and imagination start to blur, even the strangest ideas deserve a moment. Let's take a breath and just let that float for a while. This heat death, this great stillness might not be the end, but the hard pause before something reassembles. Not quickly, not predictably, but eventually. And even if it never happens, even if this really is the last chapter, then that makes the memory of what came before even more precious. You, right now, thinking about this moment in the cold future, that's part of the story. The universe made something that could reflect on itself, even across the distance of death. That's something, isn't it? Now feel the emptiness spreading out around us. We've flown so far into the future now, there are no stars left, no planets, no galaxies shining in the distance, just a few black holes, still hanging on. A few last neutron stars, spinning slower than ever, and countless black dwarfs, the cold husks of once bright stars, floating in the dark. There's no light anymore. That might sound lonely, but it isn't really. It's peaceful, like standing outside on a windless night, wrapped in silence. Nothing is happening, but everything feels settled. Let's keep drifting. Even black holes have lifespans. Some of them will last longer than others, depending on how big they are. The supermassive ones, the kind that sit in the hearts of galaxies, will take the longest to fade. But given enough time, even they'll vanish. Gone, like a ripple that finally flattens out. When that happens, the universe will be down to its quietest state yet. What's left? Not much. Maybe a few stray particles. Some photons of light, stretched so far by the expansion of space that their energy is barely measurable. A bit of low-level radiation. A few lonely electrons, or neutrinos, coasting through space with no place to go. But nothing with structure, nothing hot enough to shine, nothing dense enough to collapse. No more gravity making stars, no more reactions, no more anything. This is the heat death. Not heat as in fire, but heat as in energy and the lack of it. The energy of the universe has been used up, spread out, diluted across a space so vast and so cold that nothing can happen anymore. It's reached what we call maximum entropy, the point where everything is balanced, and because of that, nothing can change. And that's the end. Not a crash, not an explosion, just stillness, an equilibrium so complete, even time starts to feel meaningless. But let's not rush there. Let's linger. Reach out with your thoughts, and you might imagine the last few events taking place before everything goes fully quiet. A black dwarf exploding, maybe, after a collision. A final spark, releasing light for a few brief hours before fading again. One last interaction between particles that have been drifting through space alone for quadrillions of years. Like fireflies blinking once in the distance, then never again. And then, nothing. We're standing, or rather, floating in a universe that's gone completely cold. The temperature here is just above absolute zero. That's as cold as physics allows. It's not icy. It's not a chill you'd feel on your skin. It's the absence of all motion. Atoms barely twitch. Molecules no longer dance. Even the smallest vibrations have faded out. There are no seasons, No light to mark the passage of time. No gravity wells to orbit. Just darkness, spread flat and even. But isn't it strange? Even in this stillness, the universe exists. There is space. There is time. There are the final scraps of matter, barely clinging to existence. And maybe, just maybe, the faintest trace of memories. After all, you're here. And I'm here, drifting in the dark, thinking about everything that came before. Maybe that's what makes it beautiful. Not the ending itself, but the fact that we can imagine it. That once, long before the silence, the universe burned bright, that stars were born, lived and died, that galaxies spun like giant pinwheels, that comets soared and planets bloomed, and somewhere, on a blue world bathed in sunlight, creatures looked up and wondered what it all meant. And maybe some of those creatures told stories like this one. Maybe they too floated in thought across the vastness of space. Maybe they whispered to one another about the end of everything, not with fear, but with awe, with quiet respect for the incredible length of the journey. So let's keep going, just a little further. Because the thing about the heat death is that it's not a point in time, it's a process, a slow, gradual slide into stillness. It takes time. So much time that even trying to name the number of years is like trying to count the grains of sand on every beach on every planet that ever was. And even then, you'd still come up short. You and I are part of that process. Tiny, momentary beings floating through one thin thread of time. But the fact that we can tell this story at all means something. It means we came from a universe that once burned bright enough to ask questions. A universe that once was alive with motion and warmth. Now feel the hush of it. A silence so deep it's almost comforting. The kind of quiet that doesn't need to be filled. The kind of quiet that simply is. You've made it this far. Thank you for staying with me. Let's keep floating a little while longer. It's quiet now, but we're not in a hurry. The stars are gone. The galaxies have unraveled. Even the black holes are vanishing. But the story still has pieces to explore. Look around. There's no light to guide us, but we're still drifting through what remains. And here's something worth noticing. Space itself is still expanding. You might think, with nothing left, no stars, no clusters of galaxies, no bright lights, that the universe would just sit still. But it doesn't. It keeps growing, stretching. The space between everything keeps increasing, quietly and relentlessly. This expansion isn't slowing down. In fact, it's speeding up. Even now, in our current age, galaxies are being pushed farther and farther apart. The most distant ones are moving away from us so quickly that their light will never reach us. One day, our night sky will go dark, not because stars have died, but because their light can no longer cross the vast gulf of space between us. They'll still be there for a while, but we won't be able to see them. In this far, far future we've entered now, that process has long since gone to its conclusion. The galaxies that were once scattered across the sky have vanished from view. Every galaxy has become isolated, like islands in an infinite ocean, drifting so far apart they no longer know each other exist. Reach out and feel the space around us expanding. You won't feel a breeze. There's no rushing wind. It's more like the slow pulling of a rubber sheet, stretched so far you can't see the ends. This expansion doesn't need stars or galaxies to continue. It's built into the fabric of space itself. And because of that, even the few remaining particles, those last lonely bits of matter, are being carried farther and farther apart. That matters, even now, because in order for anything to happen, particles have to meet. For heat to flow, for reactions to occur, there has to be contact. But in this stage of the universe, everything is too far apart, too cold, too still. There's no energy difference to drive movement, no clustering, no new formations. Even time starts to feel irrelevant here. What does it mean for a second to pass if nothing happens? If no atom moves? If no light flickers? If no signal travels? But time is still moving. It's just moving through silence. Let's take a closer look at what actually remains in this ultra-far future. For one, there are still protons, at least we think so. Protons are what make up the nuclei of atoms. They're incredibly stable. We've never seen one decay. But some theories suggest that they might, given enough time, a truly mind-bending amount of time, 1,000 trillion years or more. If that theory is true, then even the atoms themselves are doomed to fade. Imagine that. Matter, not just stars and planets, but the very building blocks of everything, slowly breaking down into smaller particles, and then into energy. Not energy you can feel or see, just the faintest ghost of motion. We don't know for sure if that will happen. It's one of the great mysteries still unanswered. But if it does, then the future of the universe is even quieter than we imagined. Because once the protons are gone, there's truly nothing left to do anything. Even before that, though, the universe is already in its heat death phase. Why? Because heat death doesn't require total destruction, it just requires balance. Thermodynamic equilibrium. That's a fancy way of saying everything is spread out evenly. No clumps, no movement, no heat flowing from hot to cold, just everything the same, everywhere, forever. Picture a glass of water sitting perfectly still on a table. Not shaking, not steaming, not cooling or warming. That's equilibrium. Now imagine the entire universe becoming like that, but colder than the coldest freezer you can imagine, and larger than any number you could ever say. Let's float gently past a few lonely particles still coasting through this ultra-cold space. They're not part of anything anymore, just free agents, disconnected from everything. And here's a strange thought. Some of them may never encounter another particle again, ever. They'll just go on drifting through nothing, with nothing to bump into, forever. Even light at this point is stretched so far by the expansion of space that it carries almost no energy. It's like an echo of a whisper, too faint to ever warm anything, too long to ever interact with a molecule. If we could see in these wavelengths longer than any wave we've ever detected, the universe would look ghostly, barely shimmering at the edges. But to the naked eye, it's just darkness. A clean, perfect, peaceful darkness. And now we come to a truly astonishing idea. Even with everything gone, some physicists suggest that quantum events might still occur, that tiny fluctuations in empty space called quantum fluctuations could, in theory, produce new particles, even perhaps new universes. We don't know if that will happen, but the possibility lingers like a quiet postscript at the end of a very long book. Maybe the heat death isn't the end of all things, just the end of this chapter. Maybe, somewhere in the silence, the seeds of something new will stir. Or maybe not. Maybe this really is the final state of everything, a universe that had its moment of light, and then cooled into a state of perfect stillness. Either way, you and I have made it all the way here, to the final fade-out, to the last ember of motion. And you know what? It's not scary, it's not sad, it's calm, like a vast library where all the stories have been told, every chapter read, every page turned, nothing more to add, and nothing missing, just quiet. Let's stay together in this calm for just a while longer. There's something strange, isn't there, about picturing a universe with nothing left in it, and still realizing that space itself goes on. You might expect everything to just stop, for the lights to go out, and the curtain to fall. But there's no curtain here, no edge to space, no wall, no boundary. The universe doesn't shut down, it just keeps being empty, still, and immeasurably vast. So even now, long after the last star went dark, the stage is still set. The performance is over, but the theatre remains, silent, unchanging, but still present. Let's float through that quiet now. We pass the ruins of what was once a galaxy cluster. Not that we can see it anymore. There are no shining stars to guide us, no glowing nebulae, no dancing clouds of dust. But the positions where galaxies once turned, like graceful dancers in orbit, are still here. A few black dwarfs may linger, invisible in the dark. An ancient black hole may still be evaporating, particle by particle. And through it all, the space between everything continues to grow. You and I, we're just drifting with it. No need to steer, there's nowhere to go, and no rush to get there. The expansion of the universe is driven by something we don't fully understand. We call it dark energy, not because it's spooky or dangerous, but because it's mysterious. We don't know what it is, only that it exists. Whatever it is, it's causing space to stretch faster and faster over time. That's why even the lonely remnants of matter will eventually lose track of each other. There will come a point when the speed of expansion between any two distant objects is greater than the speed at which light can travel between them, When that happens, they lose contact forever. This means that, one by one, even the quietest corners of the universe become isolated. A single particle, left completely alone, might become the last meaningful structure in its region of space. And then, one day, it too might decay. Let's zoom in on one such particle. Tiny, insubstantial, maybe a proton, or maybe something even smaller, a remnant left over from a decayed atom. It's been coasting through space for more time than all the history of stars combined. And finally, it breaks apart, not violently, just quietly, into a spray of energy that barely moves the temperature needle of space by a fraction of a degree. And now it's gone. This is the level of subtlety we've reached. Everything is so cold and so stretched that even decay, even change becomes a whisper in an infinite cathedral of silence. But still, there are things to notice. Even if all matter decays, radiation remains. Low-energy photons, spread so thin they no longer interact with anything. They pass through this dead universe like ghosts, not absorbed, not blocked, just drifting. We can imagine the temperature of this future universe, and it's a fascinating number, a fraction of a degree above absolute zero. Absolute zero is the lowest temperature possible, the point where atoms stop moving completely. The cosmic background radiation we observe today is around 2.7 degrees above absolute zero. But in the heat death, the background radiation will be stretched out so far by expansion that it drops to almost nothing. So when we say the universe is cold, we don't mean chilly. We mean almost completely motionless, stillness on a cosmic scale. And what does that mean for time? Well, time keeps moving forward, but with nothing changing, it starts to lose its meaning. In our world, we feel time through movement. The earth turns, the sun rises and sets, we age, things grow and decay. But in a heat-dead universe, there are no sunrises, no growth, no ticking clocks, just the endless, unchanging dark. Time still exists, but it no longer leaves footprints. Let's think about what might still be happening. Deep down in the quantum foam, the seething, invisible jitter of energy at the smallest scale of reality. Even in what we call empty space, there are tiny fluctuations, little trembles that come and go. It's possible, though not guaranteed, that, given enough time, these fluctuations could give rise to something strange. Maybe even another universe. That idea that from the cold silence of one universe, a new one could bubble into being, is called eternal inflation. It's a hypothesis, not a certainty. But if it's true, then our universe isn't the only one. It's one of many, and its heat death might not be the end of all things, but simply the fading out of one particular song in a much larger symphony. Still, we don't know for sure, and so we return to what we do know. That this universe, our universe, had a beginning, that it expanded, that it gave rise to stars, galaxies, planets, and life, that it aged, and that, in the very, very far future, it will run down like a watch that's wound all the way to the end. What happens then? Nothing. And everything. Because even if no new things form, the story of the universe is still written in its silence. Every particle that ever existed, every burst of light, every world, every idea, they all mattered. They all led here. Feel the stillness deepen around us. There's no wind here, no echo, no distant starlight to follow, only the faint shimmer of ancient space, stretched so far that it barely remembers what light ever was. We're moving gently now, gliding through what remains, not ruins, not wreckage, but a kind of final peace. This is what the heat death of the universe means. Not fire, not collapse, but quiet. It's not an ending in the way stories usually end. It's not a crash. It's a dimming, a cooling, a long exhale of everything that ever was. There's something oddly comforting about that, don't you think? We often imagine the end of the world in big, fiery images, explosions, suns going nova, stars tearing themselves apart. But that's not what happens at the very end. By the time we reach the true heat death, all those dramatic moments are long past. The fireworks are over, the theatre is empty, and still the curtain never falls. Now, let's drift through a different kind of stage, one where even the actors are gone, but the stage lights, dim though they are, haven't flickered out completely. If we were to pause here, in the deep time silence, and try to measure something, anything, we'd find almost nothing left to measure. The temperature, near absolute zero. The density of matter, so low that entire regions of space might not contain a single particle the size of a proton. The energy, spread so thin that it's functionally unreachable. Still, things continue, in their way. Let's focus now on one of the few players left in this silent play, the black dwarf. Remember those? They were once stars, big, glowing stars, burning brightly in the early universe. They lived their lives. They fused hydrogen into helium, helium into carbon, and eventually they ran out of fuel. Some exploded, some collapsed. But some, especially the smaller ones, simply cooled down. A white dwarf is what remains of a low-mass star, and over unthinkable timescales, those white dwarfs grow dimmer, cooler, and darker, until they become black dwarfs, dead stars that no longer shine, no longer radiate heat in any meaningful way, just heavy, cold, and quiet. They sit there in space, waiting. Here's a strange fact. Black dwarfs don't exist yet. Not one, because the universe isn't old enough for any white dwarf to have cooled that much. We're talking about time frames longer than the current age of the universe by factors of millions. But one day far, far in the future, they'll be the last complex structures around. So here's where we find ourselves now, among these quiet tombstones of starlight, not glowing, not moving, just existing. But even black dwarfs don't last forever. Over absurd amounts of time, longer than anything your mind can comfortably hold, even these will decay. Through a slow process called proton decay, they will simply dissolve, not explosively, not dramatically, but bit by bit, atom by atom, into nothing. And that might take something like 10,000 trillion years. Wrap your mind around that. 10,000 trillion years. That's the lifespan of a black dwarf before it becomes nothing more than a soft memory in the silence of an expanding universe. Let's move past one of them now, quietly. It looks like nothing dark against the dark. You can only feel it, like a weight hanging in the middle of nowhere. It doesn't greet us. It doesn't even notice us. But once, long ago, it lit up its corner of the sky. Now it drifts in quiet. And after some long wait, it will be gone too. As we continue, there's another type of remnant still around, black holes. These too are relics of stars, but where a black dwarf was once a soft, glowing ember, a black hole is something stranger, a deep well in the fabric of space itself. You can't see into it. You can't see out of it. It simply is. But even black holes are not eternal. Over vast lengths of time, they evaporate. Slowly, almost lazily, they give off what's called Hawking radiation, a tiny, slow trickle of energy, like a leaky faucet in an otherwise silent house. It's not fast. A black hole with the mass of a star might take over a Google years to evaporate. That's one followed by 100 zeros, a number so large it barely seems real. But time, in a heat-dead universe, is plentiful, so the black holes too wait. And then they disappear. Not with a bang, not with a flash, just one last puff of energy, and then nothing. No more stars, no more planets, no more light or heat. But we're still here, floating in this deep, growing sea of darkness. You might reach out now and try to touch something, a drifting particle, a wayward bit of energy, but there's almost nothing to find. We are truly in the quietest chapter of cosmic history. Even language starts to lose its grip here. We're not used to describing nothing. We're not used to stretching thought across such long, empty distances, but let's try. In this future, there is no time of day, no seasons, no gravitational pulls to create tides or orbits. There are no clocks, no beating hearts, no spinning worlds. The music of the universe, the rhythm that once made galaxies swirl and stars pulse and atoms dance, has faded to silence. But silence isn't the same as absence. There is still space, still the faint shimmer of energy, scattered impossibly thin across an ever-expanding void. And there is still the memory of everything that came before. You and I, here together in this imaginary journey, are part of that memory, part of the story, because we imagined it, we remembered it. And that makes it real, in a way that no black dwarf or lost proton can ever quite erase. We've left behind the stars. We've watched the black dwarfs fade. We've seen black holes gently vanish into the invisible sea of nothing. And now, here we are, somewhere so far into the future that there's not even a word for this era that truly fits. It's not cold in the way winter is cold. It's not dark like night. It's something else. A silence that has never been interrupted. A slowness that makes glaciers seem fast. Look around, or at least try to. The black canvas around us doesn't twinkle. There are no galaxies here, not even the faint whisper of starlight bouncing off dust. No planets to circle. No moons to cast shadows. What little light still exists is so spread out that it might take billions of years to cross the distance between one lonely particle and another. And yet, we are not nowhere. We are in a universe still expanding, still stretching. You might wonder, what's it stretching into? That's a good question, and one that doesn't have an easy answer. But picture it like this. Space isn't expanding into something else, like a balloon into a room. It's more like the space between things is increasing, as if every step you take stretches the floor beneath you and the sky above you. No edges, just more and more in between. Now picture this. Two particles, once neighbors, are now separated by a distance greater than the entire observable universe used to be. They still exist, technically, but they might never touch again. Might never even feel each other's presence again. The universe has become a place where even closeness is a forgotten luxury. We drift further now, into a moment when time is almost meaningless, not because it's stopped, but because there's nothing left that changes. Imagine living in a world where nothing ages, nothing moves, nothing even vibrates. No ticking, no growing, no falling, just stillness. And this is where the idea of heat death comes into focus most clearly. The term sounds dramatic. It has the word death in it after all, but the reality is quiet. It's not a sudden event, it's a state. The universe has reached maximum entropy, meaning everything is evenly spread out. No hot, no cold, just uniformity. In a way, it's the ultimate equality. Every particle, every whisper of energy is as far from usefulness as every other. Nothing can do work. Nothing can fuel anything else. It's like all the batteries in the universe have drained completely, and there's no way to recharge them. And yet, the story doesn't stop. Even now, there's a kind of delicate persistence. The last bits of energy stretched almost infinitely thin still drift. They still are. The expansion of space continues, slowly, tirelessly, relentlessly. You might notice, in this great emptiness, how quiet your thoughts become. There's no noise to compete with them, no motion to distract them. It's like being inside a blank page that stretches forever in every direction. You and I, we hover here together, no longer as visitors to stars or companions to black holes, but as silent observers of what remains when all the chapters have been written. It might sound lonely, but loneliness depends on remembering what once was. Here, there's almost no memory, no echo of galaxies, no whisper of warmth, just a place so still that the very idea of loneliness can't stick. Now let's turn our gaze inward, not toward matter, but toward the structure of space itself. Because, even in this emptiness, there are questions waiting. Could something new ever emerge? Could the universe reverse, reboot, rebound? Some theories once suggested the idea of a big crunch, a reversal where the universe collapses in on itself, leading to another Big Bang. But that seems unlikely now. Everything we've observed tells us the expansion is speeding up, not slowing down, as if the universe isn't coasting to a stop, but racing faster into emptiness. It's like a balloon inflating with more and more space between the dots on its surface. But unlike a balloon, it will never pop. It will just keep going. So no crunch, no reversal, just a slow and steady stretching of everything, until there's barely anything left to stretch. Another idea once floated through our minds, the thought of a big rip, a scenario where the expansion becomes so extreme that even atoms are torn apart. Even space itself, they say, could be pulled apart. But that would require a kind of dark energy more aggressive than what we seem to have. Most likely, a flat ending, not with a bang, not with a tear, but with a very, very long fade. And through this, the fundamental forces, gravity, electromagnetism, the forces that hold atoms together might not change. They just have nothing left to act upon, like musicians without instruments. dancers without a stage. But still, time continues. Or does it? Here's a strange thought. If nothing ever changes, does time still have meaning? Time, after all, is just a way to measure change, movement, decay, life. But here, in this frozen stillness, what is there left to track? Maybe time hasn't stopped, but it stopped being useful. So now we drift through a kind of timelessness, not because time is broken, but because it has nothing left to do. Imagine that a clock that still ticks, but every tick sounds the same, and nothing ever happens between one and the next. That's where we are now, floating in a universe not of motion, but of persistence, a place that simply is, not because it wants to be, but because there's nothing left to change it. But here's a soft, strange possibility. Maybe even in this cold emptiness, the seeds of something new are hiding. Tiny quantum fluctuations, random, unpredictable pops in the fabric of space might still happen. They'd be rare, incredibly rare, but over enough time, an absurd, impossible amount of time, maybe one could become something, a new particle, a new burst, a new universe. It's a wild thought, but one that some dreamers love to chase. The idea that from perfect stillness, something could still be born. That even the last breath of the old universe could carry the first whisper of the next. We don't know. We may never know. But for now, we stay here, together, listening to the softest silence imaginable. You might reach out your hand now and feel nothing press against your skin. No air, no warmth, no weight, just a gentle, endless hush. And in that hush, we find the final beauty of the heat death, a universe that, after living, burning, glowing, collapsing, expanding, has finally come to rest. It is not tragic, it is not violent, it is simply quiet. We continue now, not walking or flying, but drifting, as if thought itself were the only current left in a tide that has otherwise gone still. The universe around us has quieted to the point where silence has texture, like the softness of a thick fog. But this fog isn't made of water or air. It's made of potential things that could happen, if only the universe had the energy left to let them. We are adrift in a sea where temperature means almost nothing. The idea of heat becomes strange, alien. There are no stars left to radiate warmth, no friction, no flames. Even light, when it happens at all, is so faint that it takes trillions of years to move from one lonely particle to another, if it ever does. The energy is not gone, not truly, but spread so thin it can no longer stir anything to life. Entropy has had its way with everything. You might remember entropy from before the slow drift toward disorder. It's not chaos, not really. It's just a natural tendency for things to spread out, to equalize, to stop being special. In the early universe, everything was a miracle. Stars burned bright, matter clumped into planets, galaxies spun and collided and birthed more light. But now, all that structure has unraveled. Not violently, not suddenly, just slowly, patiently, like a candle that burns down not in a gust of wind, but in a room so still, you forget the flame was ever there. Somewhere far, far from here, not a place you could point to, because directions have lost meaning, a particle vibrates, just once. That's the most exciting thing that's happened in this region of space in 1 billion years. But no one sees it. It doesn't trigger anything. It just happens, then fades, a little whisper in the nothing. You might ask, how do we even know this state could exist? Because physics, that ever-curious set of rules written into the bones of the cosmos, doesn't just describe how things are. It also gives us glimpses of how things will be, if time is allowed to play out long enough. And time, right now, is doing exactly that. It's playing out, not in bursts, not in climaxes, just in an endless, slow unfolding. No page turns, just more blank paper. Let's take a closer look at this cold, stretched space around us. The galaxies we once knew, long since evaporated or absorbed. The black holes we saw consuming stars, long gone, evaporated through Hawking radiation. They didn't explode, they didn't scream. They just shrank, pixel by pixel, until they were no longer there. And now, what's left? A kind of cosmic mist, not made of water or dust, but of ghostly particles and weak radiation, each piece moving without urgency, without destination, without resistance. Everything is so spread out that interaction is nearly impossible. Atoms no longer find each other. Light no longer reflects. Chemistry, that ancient dance of combining and changing, is over. There are no molecules forming, no reactions flaring into being, just particles, floating through a vastness so large that they might go forever without brushing against another. Time feels different here, not because it's faster or slower, but because it's empty. In the absence of events, moments lose their anchors. There's no sunrise, no ticking clock, just a gentle, ceaseless drift forward. The arrow of time still exists, but it no longer points toward anything. Even gravity, that once commanding force, is now a whisper. There's almost nothing left to pull on. Space is flat, stretched, thin. It's not that gravity has weakened, it's just that everything is too far apart for it to matter. And yet, there is still structure, in a way. Space itself still has shape. The laws of physics still apply. They govern what little is left, like a caretaker tending to an empty garden. Here, in this final chapterless chapter, we float through what some call the dark era of the universe. Not because it's evil or sad, just because it lacks light. But even in the dark, there's a strange kind of peace. There's no fear here, nothing left to threaten or break or end, just a kind of final stillness, a completion that keeps going. And strangely, the further we go, the more we begin to notice something else, something underneath all the silence. Possibility. Because even though the universe is in its lowest energy state, the rules still allow for surprises. Tiny ones, quiet ones, things that don't break the peace, but could, in time, create ripples. Tiny quantum fluctuations, random shifts in energy that occur even in a vacuum could still happen. They're unpredictable, incredibly rare, but they're not impossible. And given enough time, far more than we can wrap our heads around, one of those fluctuations might become something more. Not today, not tomorrow, but eventually, a new spark, a ripple that grows. A tiny, self-contained universe blooming out of the darkness, unfolding into something wild and new. It wouldn't be part of this universe exactly. It would be a pocket, a bubble, a new beginning floating on the surface of the old. It's only a theory, of course, but it's not fantasy. It's written into the math, sitting there like a note scribbled in the margins of everything we know. Given time, the vacuum might bloom again. And so we drift, not toward an ending, but into a silence that still carries the echo of creation. A silence that might someday, somehow, whisper itself into sound again. But for now, we are here together, moving through the softest chapter of reality. No stars, no heat, no movement, just the slow, eternal unfolding of space itself. Then maybe it'll collapse into a white dwarfdony, dim, but still warm. That warmth will last for a while, a long while, trillions of years, but even that little ember can't burn forever. Picture it now. That star you touched a moment ago is gone. Not completely. Its ashes remain, cold and pale, floating silently where fire once danced. No more light, no more heat. Just a faint ghost of what was, and all around us, the universe is doing the same thing, slowly cooling, slowly dimming, quietly becoming still. It's not that the universe stops existing. No, it's more like it stops changing. Nothing new, nothing alive. Everything has happened already, and now it's just waiting. Not for something to begin, but for everything to finally, gently, end. You might be wondering how long all of this takes. The answer? Longer than we can truly grasp. We're talking trillions of years, and then trillions more. After stars fade, even black holes will begin to disappear. Yes, even those mighty creatures of gravity don't last forever. Let's move closer to one now. Feel that strange pull around you? That's the black hole's grip. It's like the universe's way of gathering leftovers. It swallows stars, gas, even light itself. But it doesn't roar, it just eats, silently, patiently. And deep, deep into the future, even this black hole so huge, so unstoppable, will slowly evaporate, not in an instant, in whispers. Little bursts of fading energy, so faint you could miss them if you blinked across 1,000 years, but they'll add up, they always do. Eventually, the black hole will shrink, bit by bit, and then one day, it'll be gone. Not with a flash, just gone. The place it occupied will be empty, but the universe will remember it was there. Now take a breath. Look around. No stars, no planets, no light, just particles drifting alone in cold space. Everything is spread out. There's no warmth, no movement, no spark. This is what we call the heat death, but it's not hot, not anymore. It's named that way because all the usable heat, the energy that powered everything, is gone, spent, dissolved into silence. Reach out and listen. Can you hear anything? Neither can I. The universe isn't making noise now. There's no more thunder of birth or song of stars, just the quiet murmur of memory. You might wonder why this happens, why everything must end. But the truth is, the universe is playing by rules it can't break. Everything runs down eventually. Like a wind-up toy that slowly stops ticking. It's not sad exactly, just natural, peaceful, in a way. The universe didn't crash or burn. It simply slowed until there was nothing left to slow. Let's drift through it now. See that faint particle glowing gently? That tiny thing used to be part of something big. Maybe a planet, maybe a star, maybe even a living being once. But now it's alone, floating through a sky that will never brighten again. And all around it, nothing stirs. This is the final picture. The long, quiet echo after every song has ended. The air after every wind has stopped. The sky after every light has gone out. But in all of this silence, you're still here with me, still listening, still imagining, and that means something. Even in a universe headed toward cold stillness, the fact that we're wondering about it now means the story isn't over yet. Not for us. So let's keep moving. You might be asking, when exactly does this happen? How far in the future? Well, we're not just talking years here. We're talking time, so vast it doesn't feel real. After the last star dies, the universe enters what we sometimes call the degenerate era. It's a strange name, but it simply means everything is falling apart in slow motion. White dwarfs, neutron stars, black holes. They all stay for a while, but eventually, even they fade. Let's float past a white dwarf now. It's dim. It barely gives off any heat, but if you press your palm toward it, you'll still feel something faint, like the last warmth from a blanket on a cold morning. That's energy, slowly escaping. Over trillions of years, even that will disappear. And when it does, what's left behind is called a black dwarf. You've probably never seen one. No one has. Not even the universe itself, not yet. Because black dwarfs don't exist right now. The universe isn't old enough. But one day, they'll be everywhere. Dark, silent balls of matter, cold as the space around them, invisible, unless you know they're there. Can you picture that? A sky not of stars but of shadows? Silent remnants of things that once burned like suns? Let's pause here, just for a second. Close your eyes if you want. Feel the weight of time. Imagine watching billions of years pass like falling leaves. At first, you might see stars flicker out, galaxies fade, particles drift apart, but eventually, there will be nothing new, just the same stillness, stretched endlessly. And even then, time will keep going. Now, let's explore something strange. Even in this cold, dark universe, tiny things are still happening. Atoms might decay, protons might vanish. The tiniest pieces of matter could simply stop being. This takes unimaginable amounts of time, but time, at this point, is all the universe has left. And eventually, every last atom, every last speck, will dissolve into radiation gentle, quiet, scattered, not harmful, just tired, spent. And when there's nothing left but that faint, even glow, the universe will be perfectly balanced. No highs, no lows, no hot, no cold, just an endless flat field of fading light. That's the moment we call the heat death. But I want you to notice something. It's not violent, it's not frightening, it's soft, gentle, like the final note of a lullaby. The universe doesn't crash its sighs. It leans back, it rests. Now let's drift a little farther, farther than we've ever gone, beyond the stars, beyond the galaxies, into that final sea of nothingness. You might expect it to be lonely here, but listen, do you hear the quiet hum of space itself? It's not sound, not exactly, it's more like a feeling. a deep hush, as if the whole cosmos is holding its breath, and in that hush, something peaceful stirs. There's something almost sacred about this moment, the end of everything, and still, we're here, watching. And maybe that's the most beautiful part, that we were here to witness the story, to feel its warmth, to see its light, to wonder how it all began and how it might one day end. Now look around one more time. Everything that weighs every planet, every sun, every drop of life is gone, but the memory lingers. In this space, every moment that ever existed echoes gently, like light bouncing through crystal. And maybe, just maybe, the end of one universe is the seed for something new, not in a way we understand, not with new stars popping into existence, but perhaps in a way beyond time, beyond space, beyond even imagination. Look closer, just ahead. There's something drifting slowly across the cold, empty dark. You might not notice it at first. It's not glowing or spinning or flashing. It's just a lonely little particle, light as a whisper, gliding through silence. It might be the last remnant of something enormous, maybe part of a planet or a star, or even something once alive. And now it's a single grain, falling through an ocean of black. Let's float beside it for a while. You and I just drifting there with it, no rush, no noise, no wind. The universe around us has changed. It used to be full of brilliant, messy energy, explosions, collisions, the birth and death of stars. But now, none of that. All of that energy has smoothed out, spread thin. It's everywhere and nowhere. Like heat cooling from a campfire into the night air until the night swallows it completely. This is what people mean when they talk about equilibrium. Everything the same temperature, everything still. No more hot or cold, no more bright or dark. Just sameness, stretching on forever. Now, don't let the quiet scare you. Let it wrap around you, soft as a blanket. There's no threat here, no danger, only time. Endless, slow, peaceful time. You might ask, is there truly nothing left at this point? No hidden spark? No secret engine humming somewhere in the dark? That's a fair question. So let's look closely. Out in this great emptiness, there may still be a few particles here and there, bits of radiation, loose photons, those tiny messengers of light. They're not lighting anything now. They just move, onward. No walls to bounce off, no eyes to catch them, just traveling through the emptiness, forever. And it's not just light. There may be a few wandering electrons, maybe a proton or two. If they haven't decayed completely, they don't gather, they don't clump. There's not enough energy left to pull them together, just distance, stillness. Imagine reaching out to catch one. You'd wait 1,000 years, maybe 1,000,000, before one floated by. But when it did, you'd feel the tiniest nudge of its presence, a whisper in the palm of your hand, a trace of what once was. This is the deep twilight of everything. Let's pause again and look back, way back to when the universe began. Back then, everything was hot, wild, fierce. Matter and energy churned together in a storm of light, and yet, it was that chaos that allowed everything we know to form. Galaxies, stars, planets, people. Every bit of warmth we've ever felt came from that early fire. But fire always fades. That's the story of time. Heat moves outward. It never gathers itself back up. You might picture the universe like a battery. In the beginning, it was fully charged, and over billions upon billions of years, it's been slowly using up that charge, powering stars, creating motion, giving life a chance. But now, the battery is almost empty. Not suddenly, not dramatically, just used up, little by little until there's nothing left to power. Let's float together through this cold, even universe. There are no galaxies now, no clusters of stars, just space. And if you listen, really listen, you'll notice the total absence of sound. It's not silence like in a quiet room. It's silence with no beginning, no echo, no return. That's the strange thing about the heat death. It's not like anything we've experienced before, because we here on Earth are used to change, to weather and seasons, to life beginning and ending. But this is change's final moment, the place where nothing else happens, because everything that could happen already did. And yet, the universe doesn't feel dead, not exactly, just asleep. like an ancient library where all the books have closed, but the stories still linger in the air. Let's go deeper still, far beyond where time seems to matter, into the truly far future. Some theories, and let's remember, these are still guesses, suggest that even space and time might begin to break down, not in a dramatic way, more like unraveling, slowly, quietly. The very fabric of space might stretch so thin, so worn, that it loses its shape. You won't feel it. It's too slow for that. But picture it, a tapestry pulled endlessly tight until the threads come apart. That's one idea about how it all ends. Not with a bang, not even with a fade, but with a kind of gentle vanishing. Others say time might continue forever, just without purpose. A clock ticking in an empty room, counting seconds no one hears. Isn't that haunting, and yet beautiful in its own way? Now, here's something even stranger. In this frozen silence, even after everything else is gone, information might still exist. That sounds odd, doesn't it? But think about it. Everything that ever happened in the universe, every atom that moved, every beam of light that shone left some kind of trace. Maybe not one we can read. But maybe the universe remembers, in its own quiet language. Some scientists think that even after the heat death, those traces might be scattered around like ancient fossils, buried in radiation, in fields of gravity, in the way empty space hums slightly in certain directions. Can you imagine? The universe keeping a diary, written in particles and waves? And in a way, we're part of that diary. You and I, right now, having this quiet conversation, this too becomes part of the memory. Now take a slow breath. Let the quiet settle in your chest. Feel how vast it all is, not just in size, but in time. This story stretches so far beyond us, and yet, somehow, we're inside it, listening, imagining, wondering. That makes us part of the universe's story, doesn't it? Not just observers, but storytellers. The ones who remember what light looked like, what warmth felt like. The ones who walked under stars and asked, how does this all end? And here's the answer. The universe ends not with fire or war, but with stillness, with balance, with a soft, quiet hush that stretches on and on. Let's move forward again. Farther still, beyond the echoes of galaxies, past the last dying remnants of matter. What's left now isn't what you might call things. It's more like the leftovers of leftovers, faint radiation, individual particles drifting alone through nothingness, not because they're lost, but because there's nowhere left to gather. There's a deep truth here, one that's strange but somehow comforting. The universe didn't die violently, it just reached a state where nothing more could happen. No more fuel for stars, no more matter to clump into planets, no more temperature differences to push anything forward. Everything equal, everywhere the same. This isn't chaos, it's the opposite. It's perfect calm. You see, all along energy wanted to spread out. That's the rule it's always followed. High energy becomes low, hot becomes cold. Everything seeks balance. And in the heat death, that balance has finally arrived. You might be wondering, how do we know this is coming? Why do scientists believe in something so distant, so invisible, so far beyond the limits of any telescope? Let me explain. It begins with something you feel every day. Heat, when you warm your hands by a fire, or sip hot tea on a cold morning. You're witnessing energy flowing from one place to another. It always flows from warmer to cooler, never the other way around. This rule isn't just for tea or fireplaces, it holds across the entire universe. Now imagine this on a grand scale. Stars are warm, glowing powerhouses. Space around them is colder, so the heat from stars spreads outward. Over time, everything gets closer and closer in temperature. It doesn't stop until everything is the same. And that's what the heat death is, the moment when every part of the universe has exactly the same amount of energy. No more movement, no more change. Let's drift past where galaxies used to be. Imagine once vibrant cities of stars, now silent. No lights, no rotation, just frozen, invisible shadows where spiral arms used to twist like glowing pinwheels. Feel that? The emptiness? It's not empty like a blank page. It's empty like the space between memories. But there's more to explore. Come closer, see that faint glow ahead. That's background radiation, the last remnant of the Big Bang. It's been cooling for over 13 billion years. Back when it started, it was unimaginably hot. But as the universe expanded, the heat stretched thinner and thinner. Now, it's just a whisper of warmth around 2.7 degrees above absolute zero. And it's still cooling, bit by bit. One day, it will be so faint, it'll be impossible to detect. That's one way we know the universe is heading toward heat death. The background radiation isn't gone, but it's fading, and fast. And when it's gone, there won't be any light left at all. Reach out, let it brush past your fingertips. The faintest wave of energy, older than stars, gliding through the dark. That's the echo of the beginning, and it's fading before our eyes. You might wonder what else fades with it. Well, remember black holes? They're not eternal either. The bigger they are, the slower they fade, but they do fade. Very, very slowly. Stephen Hawking discovered something fascinating. Black holes can leak, just a little. They lose energy through tiny quantum effects, like a slow drip from a hidden crack. Over time, trillions upon trillions of years, they evaporate completely. So even the black holes go, and when they do, they release the last bits of energy into space. Now close your eyes for a moment. Can you picture a universe without light, without stars, without atoms, where not even a single black hole waits in silence? This is the final canvas. But even here, in this distant stillness, let's not look away, because there are still stories, still questions, still wonder. One of those questions is, can anything happen after this? Some people believe this heat death is truly the end, the final page, a universe with nothing left to do. But others wonder, could something begin again? Let's drift into that idea for a moment. There's a theory called the Big Bounce. Imagine the universe didn't just begin once, but that it expands, cools, fades, and then somehow collapses and starts over, not the same as before. A new version, a new bang, a new spark. If that's true, then even the heat death might be part of a cycle, like the end of winter before a new spring. But we don't know for sure. The truth is, the universe might do that, or it might not. Another idea is that even in a dead, quiet universe, random fluctuations could cause strange things to happen. It's called a vacuum fluctuation. Picture nothing at all and then, suddenly, a tiny blip of something, maybe a particle, maybe a whole little pocket of space. It wouldn't last long, but the idea is that randomness never completely stops. It's wild to imagine, isn't it? A spark of something inside the nothing. Let's hover there together, just above the quiet field of faded radiation, feeling the calm, imagining something any blinking into existence once more. It might be rare, it might take longer than every second of time combined so far, but time is the one thing this future has plenty of. Let's stop for a moment. Let everything around us fall still, which isn't hard, since it's already still. The stars are gone, the galaxies are faded, the background radiation is cold and even. There's nothing tugging at us, nothing to hurry us forward, so we float. Now, feel time. Not your watch, not a ticking second, but the kind of time that runs beneath everything, slow and wide, like a river that never stops. It's easy to forget that time is part of space. It isn't separate. The two are woven together, like wind and sky. You and I, we live our lives inside that fabric. We walk through it like fish swimming in water. But here, where the universe has quieted, time feels different. Slower, softer. You might not even notice it at first. But in this future, in this far, stretched-out universe, time itself is stretching too. Let's float backward just a little, to compare. In the early universe, everything moved fast. Not just light time itself was rushing, galaxies forming, stars dying, particles colliding in bright, furious flashes. Change was everywhere. 1 second then felt packed with action, like a lightning storm. Now, each second is stretched thin. Imagine sitting through one heartbeat, but instead of a moment, that beat takes 1,000,000 years to unfold. That's what time feels like now. Slow as a sigh, wide as an ocean. Even now, while we drift, we can sense that time isn't stopping. It's just got nowhere to go. There's nothing new for it to measure. No changes, no events, just more of the same. This is something strange about time. It only matters when things are happening. Without change, time loses its meaning. Imagine a world frozen perfectly in place. No motion, no decay, no growth. Would you notice time passing at all? Or would it feel like you're standing inside a painting? Here, in the far future, that's what time becomes. A smooth, endless stretch of silence. A painting that never shifts. But let me tell you something curious. Even here, time may still hold power. Not over stars, not over life, but over possibility. Remember earlier, we talked about random fluctuations, strange little blips in the dark, like quantum hiccups? Well, even those need time. They happen slowly, infrequently, but given enough time, and I mean all the time, anything that can happen might eventually flicker into being. Let's picture that. You and I, drifting quietly, when suddenly a tiny bubble appears, a sudden spike in energy, not enough to form a star, or even a speck of dust, but just enough to be. Then it's gone. Nothing dramatic, just the universe twitching. And with eternal time, trillions of trillions of trillions of years, these tiny flickers may happen again and again, somewhere, somehow, maybe, just maybe, something bigger could rise from one. Some scientists call this a quantum resurrection, the idea that, in an infinite timeline, even the most unlikely things will eventually occur, a new universe, a spark of order inside the chaos. Even, and this is wild, a copy of you. I know it sounds like science fiction, but it's a real question physicists wrestle with. In a truly infinite timeline, what's the boundary between impossible and just very unlikely? Can you imagine that? You and I, talking again, not here, but in a bubble universe that blipped into existence a Google years after this one faded. It's not something to bet on, but it's something to wonder about. And wondering is a kind of time travel too, isn't it? Speaking of time travel, let's touch on that for a moment. Out here, in the cold corners of the future, there's no one left building machines, no blue glowing portals, but the nature of time, real time, not movie time, is still strange. In the presence of massive things, time slows. That's something we know from watching how time bends near black holes. Even clocks run differently when they're near something heavy. And when you move fast, close to the speed of light, time behaves differently for you than for those who stay still. You might not feel it, but it's there, a quiet bending. But now, there's nothing massive left. No gravity to curl time around itself, no motion fast enough to make it fold. So time just stretches, like a flat sheet lying still. And that makes the heat death even more complete. Not just the death of stars or light, but the end of motion, of surprise, of suddenness. Everything happens so slowly now, it might as well not be happening at all. Yet we're still here, watching. That's the magic of thought. Even when time has grown too tired to change anything, a thought can still flicker, even if only for a moment. Let's stretch out and feel the shape of time around us now. Can you sense how thin it is? Like old paper, like soft wind on a still lake. You're not aging anymore. Not really. Not in the way we used to. Aging meant change, cells dividing, things wearing down. But here, with no heat, no energy flow, nothing has the strength to change. Time is still passing, but nothing is riding along with it. You might wonder, is this eternity? Not exactly. Eternity sounds too alive, like a bell that keeps ringing. This is quieter than that, less like a bell, more like the silence after. But still, time is here, patient, open, waiting. For what? Maybe nothing. Or maybe a new beginning. Let's take that idea seriously for a moment. Some theories suggest the entire timeline could wrap around, not in space, but in time itself, curling like a loop, the end meeting the beginning. And if that's true, then the heat death isn't a death at all. Let's keep going. We've seen so much already, and yet the road ahead stretches farther than anything behind us. That's the nature of this journey. The deeper we go, the more we realize just how vast time really is. The idea of the heat death is one of those things that doesn't shout its importance. It whispers it, slow and steady, through patterns too large for one lifetime to notice. And so, we continue to drift slowly, steadily, into the quiet that the universe has prepared for itself. Out here, it's not just the stars that have disappeared, even their echoes are starting to fade. The background radiation, once a loud, energetic fingerprint of the Big Bang, is now stretched so thin across space that it barely leaves an imprint. It's like watching the ripples of a pebble thrown into a pond after an hour has passed. The water looks calm again, but if you stare long enough, you might still feel the memory of motion beneath the surface. That's what cosmic radiation has become, a fading memory of something loud and bright. Even the tiniest interactions are few and far between. No more stardust colliding, no more nuclear fusion deep inside a sun's belly, no more planets glowing with the warmth of internal fires. There's only darkness, and in that darkness, only cold particles scattered too far apart to ever meet again. The universe has stretched itself thin. The expansion that began with the Big Bang has never stopped. In fact, it has only accelerated, and as space continues to balloon outward faster and faster, every piece of matter is pulled farther from everything else. Imagine the space between atoms being pulled open until the atoms themselves begin to fade into nothing, not because they've been destroyed, but because space itself has unwrapped them. The larger the universe grows, the lonelier everything becomes. And yet, loneliness implies that something is missing, but at this point, there's no longer a concept of connection, because nothing remains to be connected. Gravity no longer brings things together. Light no longer bridges distances. Time no longer marks progress, only existence. Here, we're left with one last mystery: information. Every process, every interaction in the universe carries a kind of imprint, a trace of what happened. In our world, that's easy to imagine. A footprint in sand, the warmth left in a seat after someone stands up. But on a cosmic scale, that concept becomes slippery. Where does information go when a star dies? When a black hole evaporates? When particles scatter forever? Some scientists believe information can never be truly lost, that somewhere, even in the faded background of the heat death, the traces of everything are still encoded in the universe's structure. Every laugh, every sunrise, every orbit, frozen in the fabric of space-time like patterns woven into an invisible cloth. But if that's true, then this quiet universe is not empty at all. It's full of echoes, full of ghosts, full of silent imprints left by all that came before. Not in the way we usually think of memory. There are no photographs floating in the void, but something more subtle, a mathematical persistence, a kind of cosmic residue. If we could read it, if we had tools sensitive enough, minds patient enough, time long enough, maybe we could reconstruct every moment that ever was. The birth of the first star, the collapse of the last galaxy, the first creature who ever looked up at the night sky and asked, why? That creature perhaps is long gone, but their question? It's still floating here, somewhere, encoded in the dance of the particles that once made them. So even in the coldest, quietest moment of the universe's future, there might still be something alive, meaning it's faint, yes, hard to reach, impossible to measure. But that doesn't make it vanish. Meaning can survive in silence, in stillness, in the endless passage of time that no longer has anything left to measure. We float through it now, you and I, not afraid, not rushing. There's nothing to rush toward, no future left to prepare for, only the gentle unfolding of what remains. And still, the universe expands. Still, time ticks. Still, the fabric stretches, pulling apart even the smallest remains of what once was. And somewhere, in this dark sea of nothingness, there's a beauty unlike anything we've ever seen. Not the beauty of fire or color or movement, but the quiet beauty of balance. Perfect, irreversible balance. The heat death doesn't mean failure. It doesn't mean the universe broke or fell apart. In fact, it's the opposite. The heat death is what happens when the universe finishes doing everything it was built to do. It's the last page in a story that began with fire and ends with calm. In between came everything: stars, life, love, thought. The long sweep of time carried all of it forward. And now, time carries us to the end of that road, not with grief, but with awe. There's one more thing I want you to notice. Let's turn gently, just slowly enough to feel the shift, and look at the space behind us. It stretches forever, but it's not blank. We've come a long way. Through the burning birth of time, past the blooming galaxies, through the final flicker of stars and the hush of dying light. Every second we've imagined has built the universe into what it is now, a perfect quiet, full of what once was. Let's drift again, slowly, calmly, into the next fold of this silent universe. You might feel the stretch, just barely like a thin ripple along your skin, though there's no wind here, no air, no ticking clock, and yet something stirs. Because in the far deep of this fading cosmos, time itself begins to feel tired, not gone, not broken, just tired, slower, fainter, as if it too is growing old alongside the stars it once carried. You and I, we've talked about energy, about stars fading, about space expanding like a balloon that never pops. But there's something deeper we haven't fully touched yet. Time. Let's sit with it now. Not in a hurry. We have plenty of it all the time in the universe, in fact. Close your eyes or just relax your mind and imagine this. A place where clocks no longer tick, where seconds don't pile up, where before and after have no meaning because there's nothing left to measure change by. That's not science fiction. That's the heat death. In a way, it's not just the death of heat or energy or stars, it's the fading heartbeat of time itself. In the beginning, time moved with purpose. The universe was young and wild. Events happened in a rush. Galaxies exploded into being. Particles collided. Reactions blazed. Everything was happening at once, overlapping, unfolding. But over billions of years, things calmed down. Fewer stars were born. Fewer events sparked. The universe became quieter. And with each passing eon, the difference between then and now started to shrink. Out here, so far ahead, change is nearly frozen. We still drift forward, but it's like drifting through a fog with no direction, no landmarks. Time without change is like music without sound. It still exists, in theory, but you can't feel it. And maybe that's the strangest thing of all. Not the cold, not the dark, but the absence of rhythm. A beatless silence where time goes on but no longer moves. Can you feel it? That weightless sense that everything is still happening, but nothing is changing? We float through it like ghosts with nowhere left to haunt. And yet, here's where it gets even stranger, even more beautiful. Time may be stretched, diluted, worn thin, but it still holds memory. Not like a human memory, not like photos or smells or voices, but the kind of memory the universe itself carries, the way light bends around invisible things, the way particles echo the shape of their past, the way every piece of this endless space still knows where it came from. Let's pause in front of a lonely particle, a single proton perhaps, hanging in the void. It's been here longer than we can comprehend, trillions upon trillions of years. It's not doing anything dramatic, just existing, but its very existence is a marker of time, proof that something still is, that not all has slipped away. And this proton? It remembers, not like we do, but in its being, in its spin, in its quiet, patient motion, it carries the signature of the moment it was born. Long ago, when the universe was a furnace, when light was young and wild, this proton is a survivor, and through it, time whispers that it still holds on. Reach toward it gently now, and let yourself feel the hush of that memory. The way this one tiny particle tells a story older than every star you've ever known. That's what time has become. Not a clock, not a countdown, but a silent witness. And yet, even that may fade. Protons themselves might not last forever. Some theories say they decay, ever so slowly. If that's true, then even this little speck of memory will one day vanish. And when that happens, when the last particle winks out, time itself will lose its last companion. With no motion, no matter, and no energy, there is nothing left to mark change. The story ends not with a bang, not with a scream, but with a breath held too long. And still, there's beauty in that. The kind of beauty that's hard to grasp, because we're used to beginnings and endings, to fireworks and sunsets. But this is different. This is the beauty of total balance, of a universe that has done all it can do, that gave birth to everything, and now rests in a stillness so complete it no longer needs time. Imagine being outside of time, not trapped, not stuck, just beyond it. That's where we are now, together. And you're not just watching this, you're part of it. Every moment you've lived, Every choice, every kindness, every breath, it added something to the universe. You've helped shape the echo that still hums here, faint and slow. That matters. It really does. Because even in the heat death, there's a shadow of meaning. Maybe not in the way we expect. There are no eyes to see, no ears to hear, no hearts to beat. But the universe still holds a memory of us, in structure, in silence, in the faintest tug of gravity across a frozen span of void. So, after the universe reaches heat death, it's settled into that peaceful frozen state where everything is uniform, dark and quiet. But time, as far as we understand, doesn't stop. It keeps flowing, even if nothing much changes anymore. Picture this: the universe as a calm ocean stretched endlessly, with no waves, no wind, just smooth, endless surface. Now, even in that quiet ocean on unimaginably long timescales, tiny ripples might still appear. Quantum mechanics, the strange rules governing the smallest things, tells us that even the emptiest space isn't truly empty. Instead, it's bubbling with brief flickers of energy, fleeting, tiny blips that pop in and out of existence. So, imagine one of these rare blips suddenly becoming something more, a small bubble of space-time that starts to grow. This bubble could expand faster than light, pushing the empty, quiet universe aside and creating a new pocket of space filled with energy, heat, and matter. It's a bit like a cosmic seed sprouting in the middle of a frozen desert. Scientists call this idea a quantum fluctuation, leading to a baby universe or a new Big Bang. This new universe could be entirely separate from ours, its own bubble with its own rules, its own time, and its own stars and galaxies forming far away from the quiet remains of the heat-death universe. It's wild to think about, but it's a possibility that comes from the strange and mysterious nature of quantum physics. Or, on an even stranger note, some theories suggest the universe might cycle through phases, expanding, cooling, then somehow resetting or bouncing back to a hot, dense state, again like a cosmic heartbeat. But that's more speculative and harder to prove. What we do know is that the heat death itself, as a final state, is quiet, dark, and still a universe without usable energy or life. But the door beyond it isn't completely closed. Tiny, rare events could spark new beginnings somewhere, sometime far, far in the future. Meanwhile, in the heat-death universe, the silence would be complete, the cold absolute, and time would stretch endlessly, carrying on as the last gentle pulse in a cosmos that once blazed with life. Feel yourself floating gently backward from the vast, cold silence of heat death. The universe here is no longer the bright, roaring furnace it once was. Instead, it's a place where light is growing faint, where warmth is slipping away like a whisper in a great dark hall. The stars we once saw shining brightly are now old, tired embers, fading slowly into the infinite night. Before the heat death arrives, the universe undergoes a long, slow transformation. It's not sudden or violent. Instead, it feels like the fading twilight after a brilliant sunset, stretching into a deep, endless night. Imagine the stars around you as flickering candles, their flames shrinking and trembling. Some of the largest stars have already burned through their fuel, collapsing into dense, silent relics, white dwarfs, neutron stars, or black holes. These remnants drift silently through space, like ancient ghosts remembering a time when they once blazed with fiery life. Now, let your eyes trace the outline of a galaxy nearby. Once vibrant and bursting with star birth, it's now quiet. The clouds of gas and dust, the raw materials for new starshave, been depleted or scattered by countless supernova explosions and cosmic winds. No new stars are being born here anymore. The stellar nurseries have grown cold and empty. The light from the remaining stars is dim, their colors shifting toward the red and infrared, signaling age and exhaustion. These galaxies are beginning to resemble sprawling graveyards of once glorious suns. As you drift further, you sense the universe stretching wider and wider around you. Space itself is expanding, growing faster and faster, pushing galaxies farther apart like distant islands slipping beneath a dark ocean. You realize that beyond a certain point, the light from those faraway galaxies can no longer reach us. They vanish beyond a cosmic horizon, slipping into a silent distance forever unreachable. It's as if the universe is quietly turning its back, leaving behind regions of space untouched and unseen. The cosmic microwave background, that faint glow left from the universe's fiery birth, has also faded dramatically. Once it was a hot, bright blanket of light, bathing all creation in its warm glow. Now it's cooled to just a few degrees above absolute zero. Feel that chill, that unimaginable cold, wrapping itself gently around everything. It's colder than any freezer on Earth, colder than the void inside a deep cave. This is the universe's final breath of warmth, fading away into eternal frost. In the vast emptiness between stars and galaxies, particles drift silently. Matter becomes sparse and lonely. You might imagine drifting alongside a lone proton or electron, the building blocks of everything, enduring through time far longer than any star could. Yet even these particles are not eternal. Some scientists suggest that over unfathomable spans of time, particles themselves may decay, disappearing from existence and leaving behind a universe almost entirely devoid of matter. Meanwhile, black holes, those mysterious cosmic giants, continue their slow, majestic dance. They gobble up what little matter remains, swallowing stars, gas, and even each other, growing larger and darker. But black holes themselves are not eternal. Through a faint, mysterious quantum process called Hawking radiation, they lose mass and energy, evaporating ever so slowly, over billions upon billions of years. Imagine watching a vast black star slowly shrinking until it vanishes in a whisper of particles and light. It's a cosmic funeral of unimaginable length. As these processes unfold, the universe approaches a state known as thermodynamic equilibrium. This is a crucial moment. Think of it like a perfectly stirred cup of coffee where cream and coffee are blended so thoroughly that there are no pockets of warmth or coolness left to stir. In the universe, this means that all energy is evenly distributed. No gradients remain. No hot spots or cold spots. No differences in energy levels. Without differences, there is no flow of energy. And without energy flow, nothing happens. No stars shine. No chemical reactions take place. No life stirs. The universe becomes a place where change is impossible. Imagine floating in this perfect stillness. No light, no heat, no movement except the slow drift of particles in a cold, dark void. It's not frightening. It's peaceful, even beautiful. It is the universe's final resting place, not with a dramatic bang or catastrophic collapse, but with a gradual, gentle fading, like a candle's flame shrinking until it's just a memory. Yet, even as everything grows quiet and cold, the universe carries its own kind of memory. It holds the echoes of all that has been the birth of stars, the dance of galaxies, the flicker of life. These memories are encoded in the very fabric of space and time, in the faint traces left behind by particles and radiation. The universe remembers, even as it slips toward this eternal calm. There's nothing left to see now. Not really. There hasn't been for a long time. Even the particles have grown so distant from one another that they no longer act like a universe at all, more like individual passengers, sailing endless routes on an ocean too wide to cross. The great cosmic expansion hasn't stopped. If anything, it's all that remains in motion. The stretching of space is the final breath, the last twitch in a body that's otherwise gone still. The particles are quiet. They don't bounce or collide anymore. Each one just keeps going, endlessly, through a vacuum so vast and so diluted that even calling it space feels generous. It's not empty in the way a room might be empty. It's emptier than that. It's the kind of emptiness that forgets what fullness ever was. If you could pause and hover in one spot, which you can, because there's nothing left to compare motion against, you'd notice that time has become meaningless, not metaphorically, literally. Without change, without clocks, without orbits, there's no measure of time anymore. The universe exists in a kind of frozen eternity, where now and then no longer matter. Even the concept of waiting has lost its shape. The last remnants of warmth, stray photons, old radiation, ghostly embers of what was once light have stretched so thin that they are no longer detectable. Their wavelengths have been pulled like taffy, stretched to such impossible lengths by the expansion that they no longer interact with anything. They still exist, technically, but they've fallen out of usefulness, out of relevance. They are the last echoes of something the universe no longer knows how to pronounce. All the structures are gone. Every black hole has evaporated, leaving behind only the faintest, coldest trails of radiation which themselves have drifted outward, faded, and become part of the general fog of oblivion. Galaxies have dissolved. Stars are memories. Planets have crumbled. The things that used to orbit, to spin, to burn and pulse and grow, they've been swallowed by entropy. And entropy is no longer hungry. There's no light, no heat, no life, no movement, no noise, no surprise. Just distance, silence, stillness, and cold. And yet, you're still here, drifting, not alive, not dead, just aware, still observing, still part of it, the very last passenger in a cosmos that has run its full course. You're not floating toward a goal anymore. You're not waiting for an event. You're simply witnessing, a speck of thought in the middle of nowhere, quietly holding on to the idea that once everything was different. Maybe you remember colors, the brilliant blue of a sky, the warm gold of sunlight, the playful green of a forest. Maybe you remember laughter, voices, the rush of movement, the warmth of bodies in motion. Maybe you remember questions about time, about space, about where it all came from. And maybe you remember that no answer ever felt as big as the question itself. Now, in this final silence, all of those things feel impossibly far away, as if they happened in another universe. Maybe they did. But still, you hold them. Somehow, impossibly, memory is still with you. Not in sharp detail, those are long gone, but in the shape of things, the outline of the story, the knowledge that it happened once, that there was a beginning, that there was warmth, that there was light. And knowing that feels like something more than nothing. A final spark. You float onward, deeper into the nowhere, where even the fabric of space is beginning to stretch beyond imagination. You can feel it, though not with senses, a kind of thinning, as if the very idea of place is unraveling, like a sweater pulled apart until only a loose strand remains. It doesn't hurt, it doesn't surprise, it just is. And then, over time, or whatever's left of it, even thought begins to slow. Not stop, just slow. It becomes a rhythm, stretched out, one idea taking centuries to bloom, another taking millennia to fade. The mind becomes a glacier, creeping, patient, indifferent. Your thoughts no longer arrive in words. They arrive as shapes, as textures, as pulses of contrast in an otherwise featureless dark. You are no longer watching the end of the universe. You are the end of the universe. The last idea, the last point of view, the final perspective. And you remain, until even that changes. Because eventually, even memory will become too wide, too thin. The structures that hold it, however faint, however abstract, will finally lose coherence. The temperature, already unimaginably low, will drift infinitesimally closer to absolute zero. The remaining atoms, scattered by expansion, will stop interacting completely. No more signals, no more differences, no more meaning. And that's when it happens. Not an explosion, not a collapse, not a bright flash or sudden fade. Just a moment when there's nothing left to say, no thoughts to think, no observer to observe, not even stillness, because stillness implies the possibility of motion. Just the total, final, complete saturation of entropy. Perfect, irreversible sameness. And in that sameness, that final equilibrium, the universe, at last, ends. No applause, no echo, no memory, just the blank slate from which everything once came. And then, nothing. Not silence, not peace, not a great beyond. Only nothing. Unreachable, undisturbed, undivided. Forever. And yet somewhere, far beyond that final curtain, you could almost imagine a flicker. Not real, not probable, but a flicker. Because if something ever existed, then maybe, someday, in some strange and future, nothing. It could again. But that is not this story. This story is over. And you were here. Until the very last breath. Until the very last whisper. Until the end. Goodbye.